everyone, welcome back to Data Science. Today I brought you some new AI model and it's called Metagene 1 and the name is Metagenomic Foundation Model. So this Metagenomic Foundation Model is designed for pandemic monitoring. So whatever pandemic is there, so for that monitoring this model is made. And this is a 7 billion parameter metagenomic foundation model, and it's trained on over 1.5 trillion base pairs of DNA and RNA, which is sequenced from the wastewater. Means from the wastewater, they got the DNA and RNA from it, and they trained those DNA and RNA, means it was over 1.5 trillion base pairs. So they trained on that. And here you can see there's a paper of it, like the research paper, and I'll also add the link in the description. Here is the GitHub code for the Metagene AI, and on Hugging Face also means you can download this model and use it for your reference also. And this was a collaboration between researchers at USC, Prime Intellect, and the Nucleic Acid Observatory. So this is made by Prime Intellect and researchers at USC and also Nucleic Acid Observatory. So if you have a look at this video, so here you see the drop of wastewater in that there were the trillion DNA and RNA fragments, and from that they trained the model. Of course, it tells the story of human health, like how healthy the human is. And you see that this story has remained beyond the reach. And this person also say that we expect to see in 2 to 3 years that a risk that AI systems will be able to fill in all the missing pieces. Like it will enable many more actors to carry out large scale biological attacks, because how biotechnology advances, new frontier emerges, even to detect the biological threats before they turn into pandemics. And he also says that it's an important step forward in a race to the top on safety. And they say that we can inspire other researchers and companies to do even better. So, this is the Metagenomic Foundation model, which is trained on over 1.5 trillion DNA and RNA base pairs from wastewater samples. And it's powered by the 7 billion parameter transformer architecture, which is capable of analyzing entire microbiomes at a societal scale. It identifies the patterns and also to serve as the early warning system for the emerging pathogens. So, this would help the planetary scale early pathogen warning system to prevent the next pandemic. And it excels in detecting anomalies, useful for monitoring biological threats, and it's developed collaboratively with Prime Intellect, the USC, and Nucleic Acid Observatory. So it's also to step forward to help safeguard the humanity. Okay, so for this model, they pre-train this 7 billion parameter auto-regressive transformer language model, which they refer to as metagenomic foundation model, on a novel corpus of diverse metagenomic DNA and RNA sequences, which were about like over 1.5 trillion base pairs. And they say that it's from a large collection of human wastewater samples processed and sequenced using deep metagenomic, like the next generation sequencing methods. Unlike the genomic models that focus on individual genomes or the curated set of specific species, the aim of the Metagene 1 is to capture the full distribution of genomic information which is present across the human microbiome. And this model is designed to aid in public health applications related to pandemic monitoring, pathogen detection, means to detect the pathogens, and also the early detection of emerging human threats. And they say that we carry out byte pair encoding. Okay, so byte pair encoding tokenization, they carry out on the data set, which is for metagenomic sequences, and then they pre train their model. So, what they do, they pre train the data, tokenization strategy, and also model architecture, which highlights the considerations and design choices that enable the effective modeling of metagenomic data in their technical report. Here you see for the training, you see first the wastewater sequencing is done, means the deep metagenomic sequences of DNA and RNA. Here you can see, and then after that, the data is pre trained. means more than 1.5 trillion base pairs, BPE tokenization. Then after that, the 7 billion parameter transformer model is here, in which they do the detection of pathogen, sequence embedding, they learn the representations, even the classification of species and anomaly detection means the errors and all that stuff. So for the data, they say that the newly collected data set, it contains the material from very broad range, means tens of thousands of organisms. So those data set is collected via the metagenomic sequencing of human wastewater. And this approach with the prior genomic sequence model, which often focus on curated collection of specific species or genomic types. So here they say we also show the data collection and sequencing pipeline in the figure above. And here first the process begins with the collection of wastewater on the left, which contains the fragments from a diverse collection of species here. And then this is processed by high throughput metagenomic sequence to produce millions of pair and reads on the right, and then each consisting of hundreds of base pairs. Now the complete data set, which I already told you, it has 1.5 trillion base pairs, which is used for the model pre-training. Regarding the performance of the Metagene 1, so it has the performance on pathogen detection and metagenomic embedding benchmarks, as well as other standard genomic evaluation tasks, which is designed to evaluate models of human, animals, and other genomes and highlighting the generalization capabilities. If you look here, this color is the light green color is for the metagene 1. Here for the human virus, it's like zero point 0.8, equal to zero point 0.8. Here, human microbiome, here also it's high. In global average, also it's high. And pathogen detect 1 also it's high. Pathogen detect 2 also it's high. And even pathogen detect average is also higher than the other models. And they also construct the pathogen and anomaly detection scenarios and show the metagene's capabilities on those detection tasks. And regarding the safe, it offers capabilities. This model offers capabilities that are valuable for the biosurveillance and metagenomic anomaly detection. And here they say that the current version, it poses some minimal risk due to data and architectural choices, but they carefully weigh the benefits against the potential for misuse, particularly in synthetic biology. And they also emphasize the need for strict safety considerations for larger, more capable models. And they also say that this AI model is specifically optimized to detect the anomalies in the short metagenomic reads, means like 100 to 300 base pairs, making it well suited for tasks like pathogen detection and biosurveillance, means for the surveillance, biosurveillance, and pathogen detection. And regarding the team, here are the researchers from USC, Prime Intellect, and the Nucleic Acid Observatory. And they're also on the Hugging Face. So I'll show you here the model. They're also on Hugging Face. You can see the model overview of it, in which there's like 196 downloads last month. And here you see the usage, how you can use this model by using the code. You can use this model, or you can even add the sequence that you want to add, and then there are the tokens. You can tokenize it, then you can generate the output from the model. Then of course you can decode the generated output and also clean up the result, and then of course you can print that also. And regarding the benchmark performance, so across three tasks the evaluation was done for metagene 1, the pathogen detection, zero shot embedding benchmarks, and genome understanding, means GUE, in which it is achieving the state of the art performance on most benchmarks. So here you can see for the pathogen detection, you can see the score of it. Okay. In pathogen detect average, the metagene 1 has a score of 92.96. In pathogen detect 1, the score is 92.14. In pathogen detect 2, the score is 90.91. In pathogen detect 3, the score is 93.70. And in pathogen detect 4, the score is 95.10. Means in pathogen detection benchmark, Metagene 1 has ranked the top in all of the benchmark in pathogen detection. And in gene MTEB, so the gene MTEB, it evaluates the metagene's one ability to produce the high quality zero shot genomic representation through the 8 classification and 8 clustering tasks. So for the human virus, the score is 0.775. In human virus 1, the score is 0.828. In human virus 2, the score is 0.742. In human virus 3, the score is 0.835. In human virus 4, the score is 0.697. Here it is lesser than the other model. And in HMPD average, the score is 0.465. In HMPD disease, the score is 0.542. Here in HMPD, the score is 0.495. And in HMPD source, the score is 0.526. And here you can see in some of the models it is higher and in some it is lower. Even if we scroll down here, in some it is lower and in some it's higher. So GUE is actually the multi-species classification benchmark, which is proposed in DNA Bird 2. Okay, so here you can see the scores. In the first one is 71.4, 61.5, 83.7, 83.0, 82.2, 46.6, 68.3. And down you can see the score is 68.9, 70.8, 65.9, 58.1, 77.9, 66.0, 80.2, 64.9, 66.7, 55.3, 51.2, 58.5, 73, 65.5, 61.7, 82.3, 86.0, 93.7, 67.4, 69.9. Here you can see in some it has ranked the top, means it's higher than the other, and in some it's lower. If you like this video, do subscribe, like, and do comment also whether you like this model or not. So that's all from my side. Thank you so much. Bye bye.